Good evening. Welcome to another new season, an edition of DEBAKEY CV Live, Innovation on the Loose, streaming live from Houston Methodist Hospital here in the Texas Medical Center. I am Dr. Stuart Corr, Director of Innovation for the DEBAKEY Heart and Vascular Center. Tonight we will be learning about synthetic data. What is it? How is it used? What problem does it address? And why we need it? To that end, I'm delighted to have Dr. Michael Lesh, founder and CEO of Syntegra, alongside Carter Prince, Syntegra's Head of Business Development. Together we will understand and explore the role of synthetic data in society and how Syntegra is providing solutions in that area. Now, before we cut to our special guests, I would like to invite the audience into our discussions. Please submit your questions via web at pollev.com using DEBAKEY as the username, or you can text DEBAKEY to 37607 alongside your question. You can also add your question to the live YouTube stream. So, without further ado, let's crack on. Carter, Michael, pleasure to have you.
Thanks for having us.
Thanks so much.
So listen, we're going to jump straight in here. First, tell us a little bit about yourselves. Tell us your story. How did you get into synthetic data, and how did you get into Syntegra?
Sure. Well, I'll go ahead and start. My background is actually quite appropriate for this group because I started my career as a cardiac electrophysiologist. In fact, I was head of that department at UCSF for many years. Wound up inventing the catheter ablation procedure for AFib, invented a balloon-based catheter to do pulmonary vein isolation, and wound up starting a company. It was about 23, 24 years ago. It was when the term physician entrepreneur was a bit of an oxymoron. Now it's a desired thing to be. That company did well. It was sold to Johnson & Johnson. And then I just like the idea of finding big unmet needs at the bedside where innovation could help a lot of patients. And one of the other areas that was of interest was, stroke prevention in AFib, huge problem. And I wound up inventing the left atrial appendage occlusion device. That was Plato. Now it's the Watchman. And anyway, went on from there to start several other medical device companies. I did some digital health work, was on the boards of some companies. And then about 4 or 5 years ago, I came back to UCSF. I wanted to give back to the institution that I had spent so many years at. And the chancellor invited me as the executive director of health technology innovation. Just meant, do big things with the technology at UCSF in a way that allows commercialization, mentor faculty who want to start companies and that sort of thing. Very similar to the sort of innovation center at Methodist and TMC, Accelerator, et cetera. And one of the problem areas that was of great interest was data sharing. This was 4 or 5 years ago, the idea of big data driving precision medicine and secondary use of real world data, et cetera, was a big deal. But how do you take all of this data that sits in these silos, appropriately so, because privacy is really key? How are you able to unleash that data and allow that data to be shared with third parties, whether that be, pharma or device companies, other collaborators, even within your own institution? As getting IRB approval and everything, this can be really tough, especially if you want a large amount of data. So began to look at ways that we could solve this data sharing problem. How do you share data in the presence of a guarantee of privacy, and do so that the data you share is just as useful as the data that you started off with? Looked at a lot of various ways to do that. There's differential privacy and federated learning, et cetera. One of the areas that has become of interest is synthetic data. Now, synthetic data has been around for a very long time, 30, 40 years. If you try to go get census data right now, you will get synthetic versions of census data. However, most of the synthetic data that's out there tends to be aggregates. So here are all the patients who have had MIs, who have hypertension, who smoke. That you get that aggregated result. Or it's a rule-based thing, something like Synthia, which just provides a bunch of Bayesian rules, and out from that you turn the knob and you get synthetic data, but it doesn't really match the data that you started with. So our goal was to try to take the actual data from a medical record system or a clinical trial, create a synthetic version that matches the statistical properties of the underlying data, however you care to measure it, but do so with a guarantee of privacy. And we eventually came up with an algorithm that relies on what's called language models, GPT-2, GPT-3. Carter will tell you some more about that. And then it turned out to be this algorithm worked super well. And so we decided to start a company because we think the use of synthetic data could be really innovative throughout, the whole healthcare ecosystem, from industry to academics, et cetera.
Fantastic. So, I know the audience is going to have a bunch of questions, okay? You've just gave us a great overview there, but I'm going to turn it over to Carter. And I'd love for Carter just to give a little bit of his background, where he's from, etc. But then really specifically state, what is synthetic data, and can you give a case example of its use?
Yeah, so happy to jump in. So I guess, my background has been all in the healthcare technology space, I guess you could say. So, early on, I actually started with Epic, the big EHR company, which I'm sure many of the audience today are familiar with, for better or for worse. And, worked in a number of different roles there, actually helped launch a couple of new products and product management role as well. But, then moved on to, in the last few years, working with data from a secondary use standpoint. And so actually in my last role, prior to joining Ofer and Michael here at Syntegra, I was at Aetion, who's a large platform provider in the real world evidence space. And at Aetion, I was leading strategic partnerships, which really it ended up meaning more than anything else, building data partnerships. Given, if you're working with analytical tools and you don't have the right data, the best tools are kind of all for one, right? It doesn't really matter if you don't have the right data to answer a question. And so my job was to go out and find the right data, help build relationships with those providers. And so through that, that's actually where I was starting to run into some barriers that have become really interesting in kind of, my new life at Syntegra, where as pharma companies we were working with, we're looking for more and more specific data sets. So, as they had a new drug that was for one very specific indication or one very specific mutation or, a rare population in general, it's becoming very difficult to find the right data that was fit for purpose for those questions. Because there are the kind of the large commercial data sets out there, folks like Optum or IBM Watson, are selling data from claims providers. There's some level of EHR, and one of the best known is obviously the data being sold by Flatiron. But when you get to very specific sets or data coming from institutions like some of those within the Texas Medical Center or European data or registry data, it's very difficult to access due to some of those privacy concerns Michael mentioned earlier on. And so it's really becoming a big blocker. And so it was something I was looking to try to solve, and actually was fortunate enough to have a meeting with Michael and Ofer, who were potentially looking to do a partnership with Aetion. And we had a great conversation, and it really seemed like, wow, synthetic data could answer a lot of these questions. And so, we continued talking, and when it came time for them to look to start kind of their go-to-market efforts and start to try to commercialize some of the technology that they were building, kind of jumped at the chance to come over and join the team and help move that forward. So it's been very exciting from there. But Michael, why don't I throw it over to you to talk a little bit about synthetic data in general, and then I can kind of take back over and talk a little bit about maybe how we do it or some of those use cases.
Yeah, sure. I did kind of skip over that level of detail. So what synthetic data is it's another way to guarantee privacy. And what it really means is you create de novo a brand new set of data. Data being a patient record, name, age, gender, diagnosis, procedure, drug, etc. So all that combined times, 1 million, however many patients you have, that's an entire medical record system, EMR. And what synthetic data does, at least the way we do it, is we attempt to create a brand new data set, patient, 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 where that data is realistic but not real. So what do I mean? I mean, let's say you have, actually, Carter, do you want to put that slide up for a second? Maybe the real patients and the synthetic patients.
Sure.
So it's basically an algorithm that's used to create a data set that looks just like the real data. And this is an example I'm showing you on the screen. The patient, many of you will have seen, a 77-year-old man admitted for coronary disease. So this is what a real patient record looks like, at least as extracted into a table. There's diagnosis, coronary disease, et cetera. Interestingly, it even threw in there, is like osteoarthritis, which, not necessarily related to coronary disease, but it's part of this patient's personal record. And then you can see the procedures. Obviously, had an IM and went on bypass, et cetera. So this is what kind of a thumbnail sketch of a real patient record looks like. Next slide. Whereas this is what the algorithm produces as a synthetic data record. It looks like any data record. You could not tell if you picked this up whether this is a real patient or a synthetic patient. If you look at the first patient, mitral valve disease, heart failure, AFib, anticoagulation, and you can see the procedures that were done, annuloplasty, excision, et cetera, et cetera. So this is generally, very concretely what we're creating. These are two examples, but we can create an entire data set. Could be from a clinical trial of 100,000 patients or 10,000 patients, or an entire medical record system. And so that's really what synthetic data is. It's realistic, but not real. It looks like the data you started with. It's in the same format. There's things like OMOP and FHIR. We give back OMOP or FHIR, and again, it looks statistically like the original data, but none of the patients in the synthetic data set can be mapped back to any original patient.
So just on that note there, can you comment about things like accuracy and precision, right? You've got this synthetic data set, but how do you validate it? I mean, ultimately, you got to show evidence that, look, this synthetic data set is what it says it is, and it can be validated. So how do you do that?
Yeah, it's a great question, and it's actually something we've spent a ton of time on in really working to validate, both for our own purposes, but also, something that we're hoping to, bring to the market more broadly, given while we truly believe Syntegra's approach to synthetic data is the best today, we think the opportunity for using synthetic data is industry-wide. And so there will inevitably be, others coming to the market who we think can validate themselves the same way. But we think of this essentially as a two-part problem. The first part of that question around validation is fidelity. So basically, like you said, Stuart, it's accuracy to the underlying data. And so on that front, we try to validate in a number of different ways across a number of different metrics. The first are most basic, looking at things like univariate statistics. So, are the distribution of ages or genders or certain procedures or certain diagnoses the same across the synthetic data and the real data? Kind of moving up a step from there, we look at things like pairwise correlation. So, is the correlation between the different procedures found within the data set, are they the same between the real data and the synthetic data, both for things that are highly correlated and things that are uncorrelated? But then we actually jump to examples that go the furthest, and I can show some as we go in here, but looking at multivariate relationships or more complicated relationships in the data itself, where you may not know going in what the results may be, right? So for things like, univariate statistics, so the distribution of age within a data set, that's something like Michael mentioned earlier on, you might know with rules or you might know with population level statistics, but you can't know very granularly how the data set will work, for example, in building a predictive model. And so that's actually one of the key cases we look at in terms of validation. So building a predictive model, so for example, a gradient boosted tree on both synthetic data and real data, can you build that on the real data? Can you build it on the synthetic data and test them both against real data and get the same results, or statistically the same results or statistically very similar results? And that becomes a really powerful metric for determining how accurate the synthetic data is, because by definition, what those predictive models are doing is actually looking at the kind of the multivariate relationships of all the parts of the data. And it's also exploring from the data itself potential relationships and connections we didn't know going in. We can't tell the model, if this procedure happens, X result is more likely. That's not what's happening in building a predictive model. Instead, the results are coming from the data itself. So those are some of the results we look at in terms of fidelity of the data itself. The other bit, though, is actually privacy, which we think is very important, given it's kind of a core tenet of why synthetic data is needed in the first place. And so, like we talked about, synthetic data doesn't actually have any real patience. And, in a few minutes here, I'll actually show kind of how we generate this data, and I think that'll be helpful as well for some of that understanding of how that works. But as a result, it should be fully private, right? When you think about it conceptually, there should be a guarantee of privacy. But, as we all know, we're talking about healthcare, and you need evidence. Should isn't good enough. You actually need to prove things, show what things look like. And so on that front, we've done a lot of work in terms of developing metrics for how can you measure that, yes, this isn't any real patient, but could someone that gets a hold of the synthetic patient data, could they somehow work backwards to the real data that it was trained on? And so we have a number of different metrics on that approach. And we've actually, on that front, worked with a third party. So worked with a group called Mirador Analytics, who's a leader in the statistical certification expert determination space, to basically provide that third party stamp of approval to say, yes, this really is truly as good as it's stating to be. And we also, though, put those in terms of disclosure risk. So basically a term that, for anyone on the call or, listening in tonight, that's from a disclosure team or compliance team or a legal team or, someone who deals with disclosure risk in general, these are terms that you're very familiar with. And it really puts it into stark contrast of the privacy level we're talking about. Because, traditionally today, even when you go through complicated expert determination, which goes far beyond even the basic restrictions of HIPAA and HIPAA Safe Harbor, you're still talking about disclosure risks that are accepted of, 5% or more. However, when we're talking about the disclosure risk of synthetic data, you're always going to have at least something, right? Mathematically, you can't get to true 0.000, but instead we're looking at fractions of a percent, 0.0001% of a disclosure risk. So, mathematically, essentially as close to a guaranteed risk of privacy as you can get.
So I think what would be very helpful is if you could show how this data is kind of represented. I know you've shown me a few slides in the past of those 3D models. If you have that available, I'd love to see that.
Yeah, let me share some stuff here. I'm actually going to, Stuarts, take a step back before I show that. Ooh. Sorry. Here you go. And talk a little bit about how we do it. I think it'll make more sense as I show that visualization. And so, Michael mentioned this approach of language models when he talked about how we do what we do. And so it's a really interesting approach because language models, and these have come across in many forms as GPT-2 or more recently GPT-3, they really are born from generating natural language. So, there's examples where machine learning algorithms have been generating, machine learning algorithms have generated new New Yorker articles, or there's one out there you can look up where it wrote a new ending to Game of Thrones that's debatably better than the one that's out there. Or another very common example is writing new Shakespeare, so maybe a new sonnet. And so essentially the way these work is they train on a large set of data. In this case, maybe it's multiple works of Shakespeare, and then use that to generate new text. And basically what these models are doing is they're learning the relationship between all of the elements of that language, right? All the words and kind of their order and their relationship to each other, basically the distribution from which they're gathered. And so one element that's really important is basically being able to pay attention to everything that's come before and have that affect everything that comes after. As you go through language, what you've said impacts what you're going to say next. And so our thought was, well, that actually makes a lot of sense to potentially take to healthcare, not just in the power these models show to be able to generate new data, in this case text, but the way they think about it, where everything to come is based on everything to come that came in the past, which is exactly how healthcare works. Everything that happens to you from a healthcare perspective is based on your past history, based on something that's happened to you before. And so basically we tried to take these models, but bring it over to structured data. And so the way that works at a high level is we're essentially taking the underlying data from a real healthcare data set. So for example, the data coming out of an EHR system, those medical records. And that data is often found as, multiple relational tables. You may have a table for demographics, for conditions, procedures, labs, drugs, etc. And what we do is we take those on a patient-by-patient basis and stretch them longitudinally. So you now essentially have a a journey or a care trajectory of a patient over time, where time is a core element in kind of looking at how they, their disease, their treatments, everything has progressed. And that on its own is not a crazy concept. I mean, that's how epidemiology studies are often run, where time is a core element of the study of the progression of a disease. But what this lets us do is now think of this patient record essentially as a patient sentence. And so now that ends up working really well within the construct of these language models. And so we feed it into the language model, and what the model does is learn the relationship between all of the different elements of this patient sentence, just like it would with, say, Shakespeare. And it builds a distribution that those real records are sampled from. So, another way to think of this is any real data set you have, any set of patients in the real world, is just a set down from the overall distribution of the world, right? Nothing you're looking at is fully representative. And so there is some higher level distribution that there is, that can be learned. And essentially what we're attempting to do is learn that higher level distribution. And so once that higher level distribution has been learned, and we call that the Syntegra medical mind, we're able to start sampling down and generating new patient records. And so conceptually, this is very simplified, but conceptually the way that works is we start with, maybe it's generating a 46-year-old man. And we're looking at, well, what's the next event that's likely to happen? And the model essentially generates a distribution of those possible next outcomes. I show 3 here. In reality, you would probably have hundreds of thousands of potential different outcomes. But the model selects randomly within that distribution, within the probability. And you continue to sample down from there, building as you go until you get to a full patient record. And a really important element to remember, and this is where it works really effectively for things like those multivariate relationships I mentioned earlier on, is that every variable that's generated is based on every single thing that came before it. And that's where you start to able to mimic and replicate some of those very complicated multivariate relationships. But to show you what that looks like, I'm going to jump over to a visual tool we have here. And so what you're seeing kind of spinning around on the screen here is actually a 3-dimensional representation of a real patient data set. This happens to be breast cancer patients that come from a federally available cancer data set called SEER. And so as you look at this, it's interesting if you can kind of make out the dots for some of you watching at home. It might be hard to make out. I'll zoom in a little bit. All of these individual dots are actual patients. And so obviously those patient records are many more dimensions than, or many more variables than 3, right? So we're using a technique that allows us to basically condense down those variables to show this in 3 dimensions. And
so, Corr, just to interrupt there, like why is it that you're actually showing it in 3 dimensions? What's the significance of that?
Yeah, so the helpful thing when you look at it in 3 dimensions, it allows you to see kind of the shape and the clustering of the data, which is helpful for looking at, hey, are we replicating this data well from a synthetic data standpoint? So, for example, here you can see, if I zoom out a little more, you can see all of these kind of big clusters of patients, right? So these are some patients that are very similar to each other, meet some kind of cohort criteria. And so it looks like you might guess from a healthcare data set, right? Where you've got, a couple of clusters of very big, common types of patients, maybe even an middle 80%, if you will. But then you've got all of these little outliers, right? Maybe it's a little rare cohort over here, or, a couple of individual or even, a handful of patients all around the screen, basically some of these outlier patients. And so it allows you to kind of visualize, well, what does this data set look like? And so we then, like I've mentioned, create a synthetic version of it. And, just a kind of a reminder, we are creating the real patient records. This is just a visualization. The visualization tool isn't how we generate the data. But it's helpful to look at both together. And so this is where you can really see that the synthetic data, which is the green here, overlaid on the purple, which is the real, really mimics the structure of that of the real data. So not only kind of mimicking the central distribution, if you will, so kind of that middle 80%, those big clusters, which could potentially be done with some of those higher level kind of population statistics or rules or things like that. But what gets really exciting when you talk about the usability of synthetic data is that we're replicating all of these little outliers around the screen. All of those rare cohorts or all of those single patients get replicated and get represented within the synthetic data as well. And that's due to the language model approach we take. The one other thing that you can see within this visualization, though, that's really helpful to see is if I zoom in a little here, I can look at the real versus the synthetic data, looking at the real, which is the purple, the synthetic, which is the green. And you can see they're right next to each other in space, the patients or the dots in this case, but they're not 100% on top of each other. And that's actually really important, because if they were right on top of each other, great, we've created absolutely perfect fidelity, but no privacy whatsoever, because at that point, that would just be a copy of the real data. Instead, we're learning that distribution, like I mentioned, and creating a patient who's very similar. So sort of in the example Michael showed us some cardiovascular patients earlier, those are patients that could be from the same space. They are representative of what the real patients look like, but are not the real patients. There is no synthetic Michael, there is no synthetic Carter in the data itself. And so that becomes really important for looking at the synthetic data. So yeah, I mean, that's the not sure if there are other questions there, but that's the kind of the basics of it. You can see on the side here some of the univariates I mentioned earlier. If you're looking at the two together, it's tough to see the difference because they're right on top of each other, so it ends up looking blue. But
Wow. So again, lots more questions here. So maybe you can give us a little more information in terms of the timeline, right? So again, when I say timeline, let's compare it to, say, mobile phone development. Okay, phone development through the 80s up till now, we went from handheld to now the smartphones. So where is synthetic data on that type of technology adoption and development curve?
Yeah, no, it's a really good question, and it's actually very pertinent to sort of why now? It's always a question of like, why now? And again, synthetic data has been around for a long time, and you can imagine just doing almost like a very simple regression, extracting some parameters, and then creating something new, and that's been around for 30 or 40 years. And in healthcare, it's probably 15 or 20 years ago now, something called Synthia was created, and that's rule-based, right? You write down a list of rules. Patients with coronary disease who have hypertension have X probability of having an MI, Y probability of having sudden death, etc. And you build it up that way, but it has no relationship to the actual real data. Starting about 3 or 4 years ago, this concept of language models, GPT-2, GPT-3, sort of what Carter talked about, came to be, as also the access to very large corpuses of data, as access to high, compute capabilities, so-called GPUs and the like. So those kind of things together made this timeline, 2 or 3 years ago when we first started this was completely novel. It still is novel. No one's doing it using these language models, but it was just a concordance of technologies that became available, and that's typical how innovation happens. Innovation is evolutionary, not revolutionary, and this is a good example. So, it's at the point now where we can create a synthetic data set of 1 million patient records, and the statistics will look just like the real. Now, I should say that we're not doing images, and that people are working on synthetic images. That's around. So maybe 2 years from now in the future, we will also incorporate images. We're not creating synthetic notes, right? This is just like your main structured data. However, I would say a year or two from now, as GPUs get better and the algorithms get better, we can create synthetic notes as well.
So we're actually getting questions in from the audience, which is fantastic. I kind of want to address them. So what data safeguards do you believe are necessary?
Well, one of the most important data safeguards, having done this at an academic institution, UCSF, is the data cannot leave, period. You cannot pretend to move a single byte of data off of the place that it exists, whether it's on bare metal or it's in an instance of a cloud somewhere, private cloud. And so that was like a number one criteria for creating our method, was this model we talk about, this learning model, has to be trained on premises. So essentially, our software is what's called Dockerized, to get technical. It comes in, it sits behind the firewall of the health system, or insurance company, wherever it's deployed. And we, Syntegra, don't ever actually see that real data. the algorithm runs in situ, and the synthetic data is the only thing that ever leaves that protected environment. So that's kind of number one. It's got to be trained on-prem. You can't hand it off to a Palantir protected environment because it's just, there's not enough trust there, right? Then there's layers on top of that. There's data use agreements that are put in place. There's security protocols that that a company like ours has to go through. But it's a lot less strict, a lot lower friction than the standard type of data sharing agreement that requires IRB approval and BAA and on and on and on. So, and then you can pile up layers of reassurance. After that, as I say, we have a third party called Mirador that guarantees the privacy of the data. So all those things we found have given even the legal department an adequate level of assurance that the data is safe.
Yeah, I mean, just to emphasize that the problem you mentioned there, getting access to data and researching with data at hospitals and institutes is exceptionally difficult. It's very tedious. You could have 100 companies that want to come in and help analyze the data, 100 researchers, and each one needs an IRB, it needs resources, time, and effort. So something like synthetic data could really shift the needle in that development. But along that note, we have another question from the audience that says, what lessons could democratizing teach us now that we don't already know?
Carter, you're on mute.
Yep. I think a lot of those lessons that we can learn are tough. It's tough to say, right? I mean, I think the hope is that truly by democratizing data, one of the ideas is you're unlocking more of that brain power that can go to problems than can be there today. I mean, I think a classic case of that is you look at a research institution. Michael likes to say he was early on the physician entrepreneur front, but he was also early on being a computer scientist who was a physician. But that's not that uncommon anymore. You have lots of physicians coming up who are data scientists by night or maybe by day as well. And so as you have these folks, in particular for coming through an education, the educational part of an academic medical center, they aren't able to work with data today where the classes they're taking, the insights they're deriving are actually unlocking any new insights. And so that's just one case where as you take synthetic data to something like an educational environment, you can actually start to unlock real insights. So, as students are learning, as students are exploring, as students are, really just poking around, if you will, which is not possible with real data because, that's real patient data. Dealing with patient privacy does not fit with the concept of exploration and, kind of in seeing what you find. But that's exactly how data science really works. And, more modern techniques around machine learning, you really need to be able to do a lot of iterations, a lot of cycles, a lot of exploration. And that's what synthetic data allows, right? And so I think our thought is that a lot of that, new insight, a lot of that innovation, we don't know what it'll be yet, right? We don't pretend to have all the answers of what people will do with synthetic data. Our goal is to make it as open as possible. I think, one good way of looking at this is, the concept of data-centric data science or machine learning. And that's a concept that Andrew Ng at Stanford has been talking about a lot recently where, one of the biggest problems in driving kind of machine learning forward as a field is not how can I make my models better, but how can I work with the right data, work with more of the right data, work with better data. And that's really the problem we're trying to solve of how can you actually get more to that data-centric focus, both as an organization and kind of more for more specific instances.
Correct. And that was a great reply there. And just to add to that, I think that's actually an underlying really exciting aspect about AI in general, right? Traditional science, you have your hypothesis. You think about hypothesis, you go out, you prove it, it's right or wrong, you do experiments. But with AI, it can actually create a hypothesis for you, right? And the hypothesis it can come up with can be so out of the park that you can be blown away by it. And that really can start undercovering and bringing up brand new research avenues. So it's a very exciting place to be in, I believe. Again, we're getting more questions from the audience. They're active tonight. Another question, as care becomes increasingly automated, how can we avoid coding biases into algorithms and underlying data sets?
Extremely good question, and one that we have a partial assistance for. I don't want to say we have the solution, right? I mean, we're not really in the analytics part of the flow, We don't right now believe that synthetic data could be used for, an actual FDA-approved, device or clinical decision support system. However, you could certainly build your model on top of synthetic data, spend a year or two doing that, and then get a hold of the real data to actually build a clinical decision support system that could be, approved. As to bias, it's a huge problem, right? It's not just in healthcare; it's throughout the world of, algorithms and AI and machine learning. We see that all over the place. I will say this though: with what we call generative models, we can dial knobs. If you know that your data set has 60% men and 40% women, we can do what's called conditional generation and create a data set that's 50-50. If you know that your data set is mostly urban and just a little bit of rural, we can create a data set that's 40% rural and 60% urban, or whatever your imagination can think about as bias in the existing data. We can correct for that bias, assuming there's enough patients in the small cohorts. What we hope somebody can do society-wide is figure out where the sources of those bias are, but that's kind of beyond our remit.
Yeah. Another question from the audience: how do we ensure that the benefits are equal for everyone?
It's a super good question. One of the terms we use is to democratize healthcare data. And when you say everyone, I assume you mean every patient. But let's talk about citizen scientists. I mean, one of the things that we've been doing a little bit with the NIH and their COVID effort is to create synthetic data that could sit on a site, on a server, and anybody with adequate credentials could access, not just university, faculty, PIs, but with an email address or whatever other minimum credentials you want, you could get access to the entire COVID data set from 50 medical centers. That's a work in progress, but that's the idea. So you can imagine things called Kaggle contests. I mean, there's lots and lots of stuff. We plan on putting some of the data sets that we are bringing in, and maybe a DEBAKEY data set would be one of these, where we can just completely put that entire synthetic data set online, and students from sub-Saharan Africa could access that clinical data. So that's kind of how we think about this, as a democratization of data access. And I think with things especially like COVID, where we just are not getting the information that we really need, we're not getting the data because of privacy, and the privacy is a legitimate concern. But if you could solve for that, then that data should be made available.
Yeah, and actually, to jump on that, an area Michael's heard me talk about this many times, but an area that gets me really excited too is not just how do you bring this data to more folks to use the data, but how can you bring the benefits of innovation driven with data to more patients? That who's going to benefit from it more? And one of the populations I think about a lot is actually pediatric patients here. And so for those of you listening in that are familiar with the real world evidence or kind of secondary use of data space, pediatric data is often a space where you have little to no access altogether. There may be a lot of agreement on the reason why we should do an external control arm, or whatever the case may be for a pediatric population, get a drug into their hands quicker, or avoid unnecessary errors in the hospital. But getting access to that data has all of the same issues as adult data, but amplified. Anytime you're working with a pediatric population, those concerns increase. And so that's an area where we are starting some work with some pediatric organizations. And actually, for any of you attending, we'll be speaking at the PEDS 2040 conference tomorrow, which is a pediatric innovation conference about this. But that's an area where I get really excited because, I really think there's kind of been a lagging there due to data access of how can we take, again, that data-centric approach to improving patient care in that population, which is a incredibly important population. I think we would all agree. And so, again, that concept of democratization goes to both sides. That who can get more use of this data, but who can get more benefit from how people are using the data.
And just to add to that, you know, I think we should also cover the monetization of the data, right? A lot of people could maybe suggest that, you know, maybe to truly have to truly go forth with the democratization of data, it should be the patient himself that owns that data. In a sense, it should also mainly be sort of decentralized. And now if I'm saying decentralized, you know I'm going to say blockchain technology, okay? So is blockchain technically, could it be a competitor to you guys, you know?
So I'll say something very controversial. Synthetic data is a short-term, as in 10-year solution. I do believe patients should own all their own data. And ultimately, this will be driven by patients having some control over where their data goes. This is, you know, the whole electronic medical record system and secondary use is a byproduct of a billing system, right? You know, Medicare and et cetera. And we're sort of hacking onto the back end of that. You have the problem of a set of data that might have patients who are dead or, you know, can't give consent. So I think synthetic data is extremely useful where you have large data sets of patients where the data already exists and there's just no way to get consent from them. I think in the future, things like blockchain and the like are going to be a very good way to determine how that data gets shared. Now, that said, it's still possible that patients will choose to share with some entity or some layer, knowing that that entire layer will be turned into synthetic data, so that that synthetic data can then be used by third parties. So no matter what, synthetic data will add a layer of protection, but ultimately I strongly believe patients should have a right to this data. This is their data. By the way, I would also say it's also the physician's data. I mean, as a physician, kind of forget that. When I write in a medical record, I'm writing a note to myself and to my colleagues, and it's about the patient I'm seeing. So there is an ownership of a medical record by both physicians and patients. And I think that actually creates, you know, that whole issue will have to be worked out. But that's why I say synthetic data is a really nice way to kind of back away from that. Because really, if you think about it, it's statistical. We're taking statistical parameters that are derived from the real data. It's not the real data. We're leaving the real data to have whatever governance folks wanted to have.
Got it.
Yeah. The one other thing I would add on that, I agree with everything Michael said. You know, kind of very excited by the rise of some of the PHR companies, as I call them out there as well. I think they're doing really interesting things. But the element we talked about earlier with kind of augmentation, right? We talked about making, you know, small cohorts larger, or, you know, normalizing bias or filling holes. You know, all of those are issues that don't go away even if a patient owns their data. You know, if it's you know, a million patients who each own their own data and you're aggregating it together, you know, who's to say that you might actually not see more bias, right? I mean, I think especially the way some of that's being collected now, you're going to have an overrepresentation of people who are tech savvy, because a lot of that's coming through, you know, kind of app-based interfaces and people who know, hey, I can go out and, you know, get control of some of my data. You know, probably seeing a very biased population there. And so the ability to augment that, I think, is really important.
So we have, sorry, Corr, I'm just going to speed it on. We're almost out of time, but we have another question here from the audience. This is actually an interesting one. Is there a legal avenue that would take things where they need to be? I am interpreting that as, is there something that an institute could do in terms of legal templates and legal wording that could speed up things and allow that real patient data to be democratized?
No. The short answer is no. Believe me, there's a lot of people, there are whole law firms who have a consulting practice to try to, you know, do data sharing. It's a whole industry. And if the solution were there, we would have to be doing what we're doing.
That's a fantastic answer, no. And I think I may agree with that, you know. So a final question just for myself is, you know, you guys are using AI essentially to create this synthetic data. So you go from the real to the synthetic kind of patient, I guess. Does that mean you could use AI to retroactively go from the synthetic patient back to a real patient?
We can't, and that's actually one of the, when I talked about privacy metrics, that's one of the important things we look at. So But we look at it not from the standpoint of, do I want to go back for a good purpose, but, thinking of it from the attack standpoint, right? Of, someone attacking the data with linkage attacks or other approaches. So, one of the things we look at, for example, is attribute inference, where let's say there's an attacker who, gets a hold of the synthetic data because we've made it publicly available. But they also get access to some real statistics about Michael. And they know Michael is probably in this, in this data set, but they want all of his data. Can they work their way backwards from that to the real data itself? And so that's what we look at with attribute inference and see, is that kind of that linkage possible? And the answer that we have found to date is no. And that's what we show with the disclosure risk. If it were possible, there'd be a higher disclosure risk there of working its way back. And so there are use cases where you can see, hey, it would be really helpful to get back to that real patient. And so we see that though as a feature, not a bug, right? That linkage has been totally broken. If you want to do that look back, you should do it at more of a cohort level, right? I need to find a patient who looks like XXX, and now I go to my real data and find, turns out that was Stuart. But there is not a linkage possible there.
Got it. And now I want to make one little note here. So you guys are currently part of the TMC Health Tech Accelerator program, right? It's very exciting. So I guess, for the benefit of our community, like, what are your needs at the moment? And, like, who are you looking to engage with? Like, what do you want out of the TMC as a whole?
Michael?
Yeah, first of all, let me say that TMC Accelerator is a great program, and I've mentored lots of faculty and seen lots of these programs around the country, and this is the best I've seen. They really bring in all the pieces that you need to, start a company and move it towards commercialization, and that's super hard to do. And I'm really impressed by all the resources that are brought to play and the people in the accelerator who really understand. Look, I think one of the things, you can tell that we're super excited about this, and one of the things we're looking for in a very general way is people who would like to work with this in some way. They have a data set they want to try. They just want to learn more about how synthetic data works. So just, let's call it academic collaborators is certainly something. We're always recruiting for data scientist employees as well. So just ultimately involvement, enthusiasm that, folks want to try this out. Carter?
Yeah, no, I think that hit the nail on the head, right? Like there was a question earlier of, what are the new things this is going to unlock? We're really looking for those partners who help us find those most exciting use cases that this is able to enable. So, what's that idea you have that, hey, this would work if you could just get access to the right data to do it? That's where we'd love to work together to help you get that data.
Fantastic. Well, I think that's a great way to end this evening's show. And I just want to thank you again both for patching in. I'm looking forward to working with you guys in the future. So thank you very much. Now, ladies and gentlemen, people in the audience, I'd just like to share with you a couple of slides. There's some events happening next Tuesday. We've got something special. So this is the inaugural symposium for a newly established institute. It's the Houston Methodist Institute for Robotics, Imaging and Navigation. Brand new. If you tune in on September 28th, next Tuesday, we are going to be exploring extended reality and robotics. And next slide is just showing you some of our participants. So we've got a fantastic range of people patching in, from industrial companies to academics, both national and international. So we're really excited for that. If you want to take part, it's 3 hours. It's mirren.tech, and you can register there. And on that note, I'd like to say goodbye. We'll see you in a month or so. Have a nice evening.